All right, so this is last class we're talking about linear transformation of random variables, and today we're going to talk about combining random variables. If you missed because of Thanksgiving, we can talk about that, but you're going to have some work you're going to have to do. So combining random variables. We were using the example the other day of, a random variable was results in roulette. So combining random variables would be like, okay, well, you went to Vegas. I would say I went to Vegas, and I'm playing roulette, but my wife is playing blackjack. What would be our expected combination results? And that's what we're talking about at combining random variables. Like, what is my expected value? What is her expected value? But what happens when we put those two together? And also what happens to the standard deviations when we put them together? The means are easy. If you want the expected value of a combined random variable, right? We're saying there's a random variable x and a random variable y. So we're going to define t as x plus y. So the average of t, the expected value of t is the average of t, which is just the average of x plus the average of y. So if we combine two random variables, the average of the combination of those two random events or random variables is the sum of the means of each one of the random variables. Really easy. Just add them together. The key thing here is we can only do that if x and y are independent random variables. Right? What my betting at blackjack or my betting at roulette cannot affect my wife's betting at blackjack. Right? We can't have communication. One can't affect the other. So, and remember from last unit, our definition of independence was, the probability of A equals the probability of A given B, and the probability of B equals probability of B given A. If these two statements are true, then A and B are independent. So that's from last unit. So whenever we do these things, they're going to ask us a lot, especially in this unit, just to get used to that idea, that they ask, is it reasonable that these two events are independent? And you're going to have to think a little bit, and you're going to have to say yes or no. But we need to start, this is the big thing, is we're going to start making assumptions. And we can't just gloss over them. We have to say, is it a reasonable assumption? Because when we don't have reasonable assumptions, then none of our results after that have any meaning. All right. Here is the tricky part about combining random variables. We do not add standard deviations. And it's a whole mathematical thing, and we can get into the proof, and we'll play around with it a little bit in class. But the bottom line is we do not add standard deviations. Instead, what we do is we add the variances. So if we have the standard deviation of x, right, we were given the standard deviation of y, if we wanted to find the standard deviation of t, what we would have to do is we'd have to square x, we'd have to square y, and then we would have to take the square root of the sum. So it's the sum of the variances. The variance of t will be the variance of the sum of the variances x and y. So, but remember, variance is defined as the square. Well, actually, standard deviation is defined as the square root of variance. So we would have to square the standard deviations, add them together, and then find the square root, and that would give us the standard deviation of t. That should be a subscript. I don't know what happened there. And that's the tricky one. So we just remember, and this is the big one, and just keep circling this. You don't ever add standard deviations. Right? Don't ever add standard deviations. You do not ever add standard deviations. Never, ever, 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 ever. The other interesting thing is we always add variances regardless of what's going on. So, for example, let's say instead of total, we're going to define a new standard variable, another random variable d, and d is x minus y. So instead of adding the two variables, we're subtracting them. And the means go exactly like you would think. You just subtract the two means, and that's the mean of the differences. But, and here's where it gets a little odd, is that even if you're subtracting two variables, you still add the variances. And for a lot of people, that doesn't make sense, why that would be. So let me talk about that. So even when we're combining two random variables, you always add the variances, whether you're adding or subtracting in the combination. And I know that I went through a lot. Feel free to pause and go back. Let me just talk a little bit about subtracting two variables. So if we're subtracting two random variables, right, we're going to find the difference. Right, when we subtract them, the difference, you'll get some new, like if this is mu x and this is mu y, then the resultant will be at mu x minus y. But if I'm subtracting, there's a possibility I could do this subtraction, the furthest out. And so the new one is going to be wider. I'm sorry, it's not centered correctly. The new one will be wider than the two that we were combining because there's more variation. And that is just kind of in a nutshell why you add the variances. Feel free to pause this and go over it, and we're going to spend a lot of time on class doing a bunch of these. But that's it for the video. See everybody next class.